new video of chemistry, and today we will be talking about scuba diving. Have you ever wondered how scuba diving really works? Whether do you have to be a good swimmer to dive in? Will you ever run out of air? Or how much further do you have to dive in? This questions keeps on popping in your head and you want to know why. And I will give you a short overview about scuba diving. Scuba divers usually carry their own source of breathing gas. It is contained in a backpack-sized tank, compressed air allowing them greater independence and freedom of movement than surface-supplied divers. My friends and I will be explaining how Boyle's law is being applied in scuba diving.
Scuba diving is a form of underwater diving in which a diver uses a self-contained underwater breathing apparatus to breathe underwater. The depth range applicable to scuba diving depends on the application and training, but most dives are shallower than 30 meters. Recreational diving limits the compression to non-stop dives or relatively short planned decompression stops to minimize the risk of decompression sickness. Recreational scuba is generally limited between 30 to 40 meters.
The thing that makes all this possible is pressure. Pressure is defined as force per unit area. It is usually more convenient to use pressure than force to describe the influences upon fluid behavior. The standard unit for pressure is the Pascal, which is a Newton per square meter.
Boyle's law states that at constant temperature, the pressure and volume are inversely proportional to each other. As one increases, then the other decreases. Given in the formula P1V1 equals to P2V2. A balloon pushed underwater, for example, shrinks as its volume is compressed. Conversely, a balloon inflated underwater and released expands and may burst as it rises and its volume expands. This principle includes the foundation of the scuba safety training to prevent barotrauma or the injury to the body from the changing pressure.
A fundamental rule in scuba diving is to never hold your breath. Look at Boyle's law to know why this rule exists. When a diver inhales air from a scuba tank, the air that enters a diver's lungs is at ambient pressure. If a diver inhales from the tank on the surface, the pressure in her lungs will be at 180 m. If she inhales air from her tank at a depth of 30 meters, the pressure in her lungs will be 480 m. Assuming the diver's lung volume is 1 liter, we can complete the left side of the equation for Boyle's law. If a diver at 30 meters has 1 liter of air at a pressure of 480 m in her lungs and ascends to the surface while holding her breath, the following equation applies. 480 m times 1 liter is equal to 180 m times the second volume. Solving for the second volume, we see that the diver's lung volume would increase to 4 times its typical volume. This increase will result in severe damage in the lungs which can be fatal. The increase in volume with a decrease in pressure can also be seen in the gas bubbles exhaled by the diver as he rises to the surface.
Hearing the application from Boyle's law, make sure that before scuba diving, you must first know this tip. Always make sure to clear your ears and descend slowly, breathe steadily, and ascend slowly, which will be furthermore discussed by Mariella.
Boyle's law describes the role of water pressure in the dive environment. It applies and affects many aspects of scuba diving. As a diver descends, the water pressure around him increases, compressing the air in his ears. He must equalize the pressure in his ears to avoid pain and a possible ear injury called ear barotrauma. Ear barotrauma is caused by the damage done by increased underwater pressure on the air pocket in the middle ear. While during ascent, water pressure around him decreases and the air from his BCD or buoyancy control devices expands. This is why he has to release excess air from his BCD as he ascends. Otherwise, the expanding air will cause him to lose control of his buoyancy. Would the problem harm the diver? Yes, it would, because a 5-fold increase in the volume of gas in his system is too dangerous. Now let's do a sample problem. Divers get the bends if they come up too fast because gas in their blood expands, forming bubbles in their blood. If a diver has 0.05 liters of gas in his blood under a pressure of 250 atm, then rises instantaneously to a depth where his blood has a pressure of 500 atm, what will the volume of gas in his blood be? Do you think this will harm the diver? Using the formula P1V1 equals P2V2, we solve for the second volume by multiplying the first volume and first pressure and dividing both sides by the second pressure. The answer we would get will be 0.25 liters.
So how do we avoid the dangers? The risk in scuba diving is easy to run into, but finding different ways to avoid it is a difficult maneuver. First, make sure that all of the equipment to be used is up to date on standards and regulations. Second, check oxygen rates and pressure levels more frequently to ensure safety. Third, be cautious of the time spent underwater and check the depth. And lastly, listen to the instructor. No matter how much research you did, you are not a professional. So that's it for scuba diving and Boyle's Law. Thank you for watching.